Hi everyone, today I'll be walking you guys through a C++ project I built called My Medical Manager. So the goal of this project was to practice and demonstrate OOP in a realistic way, and I'll explain by explaining the UML design, then walking through the key parts of the code, and finally showing how the program runs so you could see how everything works together. So before jumping into the actual code, let me show you guys a little bit of my design. So at the center of the system is the abstract base class called the medical staff. From that base class, I also have two derived classes called the doctor and the nurse. And in the UML, both the doctor and the nurse point upward to the medical staff using an empty triangle, which represents inheritance, which tells us that a doctor is a medical staff and a nurse is a medical staff. So the UML here focuses only on the class structure, which is exactly what UML class diagrams are meant to show. So let's go down here to the medical staff class. So this is the foundation of the whole project. It defines the shared data that all staff members have, which is the first name, the last name, and the ID. And these fields are private, which enforces encapsulation. And more importantly, the medical staff defines two pure virtual functions, which are work and display info. So because these functions are pure virtual, medical staff is an abstract class. So this means that it cannot be instantiated directly, and every derived class is required to implement these behaviors. So the class also includes a virtual destructor, which is also important because derived objects are later deleted through base class pointers. So now I have my doctor class as well. So this actually inherits from medical staff and adds one piece of doctor specific data, which is their specialization. And doctor overrides both required functions so it can handle its own input and output logic. And this keeps doctor specific behavior separate from the shared staff data. So let's go to my last class here, which is the nurse class. So inside this class, it follows the same exact structure. It inherits from medical staff and adds years experienced right here. So both doctor and nurse follow the same interface, which keeps the design consistent and makes it easier to extend later on in the project. And something you may notice is that I don't have a menu class in the UML. I did that intentionally. The menu logic lives in free functions inside the main that I created, not inside a class. And the UML class diagrams are meant to model classes, not my other code. So these are all the header files in my project. So now let's get into the code. So in my medical staff, the shared data members are private, which actually protects them from direct access. And then I also have my getter and setters here, which provide controlled access to those fields. And the most important part of this file right here is actually the pure virtual functions. So these define a contract that every staff type must follow. And there's also a virtual destructor, which ensures that when a derived object is deleted through a base pointer, the correct destructor is called. And over here I have my constructor and my copy constructor, and I already told you guys about the destructor right here. So here is my doctor file. So this is the header file. So I have my constructor and my destructor here, and these functions overriding here. So let's get into the .cpp so I could show you guys a little bit of the code actually. So as you can see, let me just show you guys how the display info and the work functions work. So the program prompts the user for input and stores shared values like name and ID using base class setter functions. And doctor doesn't re-implement name or ID logic. It reuses that what already exists in medical staff and only adds specialization. And then in the display info, it prints formatted output using base class getters plus the specialization. So let me show you guys the nurse file now. So as you can see, it's kind of structured like the doctor file. I just added the years experienced integer right here, which is private, And it also has the destructor and the virtual function overrides and a constructor right here. So let's get into the nurse.cpp. And as you can see, it's really similar to the one that I just showed you guys with the doctor. So it gathers input and work, uses base class setters and for shared data, and stores its own years experienced. And it also displays the info method, which prints the nurse specific information while still following the same interface as the doctor. And this consistency is what makes polymorphism possible later. So yeah, so let's get into the main now. So this is my main, so obviously I have to include all of those header files so that I have that information. This is the menu I have right here. So the first option is to add a new doctor, the second is to add a new nurse, 3 is to display all the doctors, 4 is to display all the nurses, 5 is to display all the employees, and 6 is to actually exit the program. So here I use a validation to make sure that a choice from 1 through 6 is chosen. Otherwise you'll get a error message saying you have entered the wrong input and to try again. This is really important so that the program runs properly. And I'll show you guys how this actually works. So I use switch case statements and I use enum options right here, so you guys just have readability right here. So once it enters that right there, the do while loop, it'll actually go into the switch case statement. So the switch statement controls the program flow based on the user's menu choice, and each case has one clear responsibility, whether that's to add a nurse, add a doctor, display doctors, display nurses, display all employees, or exit the program. So that when displaying only doctors or nurses, the program uses dynamic cast to safely check the object's real type at runtime. And for display all employees, right here, no cast is needed. Polymorphism handles everything automatically. And another thing I wanted to show you guys is the vector. So the vector right here, medical staff. So even though the actual objects are doctors or nurses, they're actually stored as medical staff pointers. So when the program calls it, it'll push back staff. So it'll determine at runtime which versions of the function to execute. And this is runtime polymorphism, which is how it's using the virtual functions. And I also have the template function right here, which demonstrates compile time polymorphism. And as long as the object passed in has a display info method, the function works. And in this project, it works for both doctors, nurses, and base references. So yeah, so now that you guys seen the code and how everything runs with the UML and everything, let me compile this project and show you guys how the interface works. Let's just give it a second here. Okay, so it's a pretty neat interface. So let's just add a new doctor and a new nurse real quick, and I'll show you guys how the display works. So let's just add a new doctor first. Okay, so as you can see, a doctor was stored. Let's just add a new nurse really quick. Let's put 5 years of experience. Okay, so let's display all the nurses first. So as you can see, Jeff Dane, the ID number is here, and the years of experience is right here. So it's working well. Let's just display the doctors too really quick to make sure that works. Yep, stores there. And then if we want to display all employees, we click option 5, and they actually store together. So as you can see, everything is working great together. And if we actually exit the program, you'll see our destructors are working because it exits the medical staff, and the object doctor is destroyed and object nurse is destroyed as well. So yeah, so to wrap this project up, this project really shows why OOP is so important. By using abstraction, inheritance, and polymorphism, I was able to design a system that's structured, easy to understand, and easy to extend and work on later on. And if I want to add another staff role in the future, I don't need to rewrite existing logic. I have to add a new class that follows the same interface, and that's the real value of OOP and designing software that can grow without breaking what already works. So thank you guys for watching, and I hope you guys learned something throughout this video.